In this next unit, we're going to talk about something called rational functions. And if you recall, rationals are like fractions. So to start out with, we're going to use reciprocal functions. Remember, when you have numbers, a reciprocal just means you flip it over. So the reciprocal of 2 would be 1/2. The reciprocal of 5/7 would be 7/5. So if you have a function, like say you have x to the 6th, its reciprocal would be 1 over x to the 6th. Or if you have x cubed plus 2x minus 7, its reciprocal is 1 over x cubed plus 2x minus 7. Now, remember, this is absolutely not equal to splitting it up like this. That is not the same thing. It is totally different. If you have a polynomial on the bottom, you've got to keep it all together like that. Now, when we talk about these reciprocal functions, the biggest thing that we have to be careful about is the domain. Remember, the domain is any x value that we can have in the function. And you have to remember that the bottom of a fraction cannot equal 0. It's undefined there. So that's going to give us vertical asymptotes, or holes in our function, depending on how it works out. With the reciprocal functions that we're working with right now, it'll just be vertical asymptotes. With the other rational functions where we have stuff on the top besides just one, then we're going to end up with some holes. So for right now, we're just going to deal with some vertical asymptotes. So for example, let's look at this function here. Now, we have a polynomial on the bottom, and it's reciprocal of the polynomial. If we want to find the vertical asymptotes, then what we have to do is find the zeros of the bottom. Because if the bottom is equal to 0, then this function is not going to be defined. So we use our techniques that we learned from polynomials and factor this all the way down until we get all of our linear factors, and we see that x is equal to 0, -4, or 3 are going to give us 0 on the bottom. So that means that our domain is x such that x is not equal to 0, -4, or 3, because those are going to give us 0 on the bottom, which means it'll be a vertical asymptote. So let's look at some pictures with that. Let's say we have this function, we'll call it k of x, just to be different, and it's 1 over the absolute value of x minus 2. So first we ask ourselves, well, where is this function not defined? Well, what makes the bottom equal to 0? 2. If the bottom is equal to 0, if x is equal to 2, the bottom will be equal to 0. So our domain is x such that x is not equal to 2. So it can be anything else, it just can't be 2. So what we have in our graph is what we call a vertical asymptote. Hopefully this looks familiar. And it's basically a dotted line that we put in to show us that the function doesn't go there. Now, the range on this graph, you notice this is an absolute value. Well, what do we know about absolute values? We know they're positive. So we know that y has to be greater than 0. Well, why can't it be equal to 0? Well, if you have a fraction and you have a number up top, there's nothing you can plug in for x. It's going to make this equal to 0. So y equals 0 is a horizontal asymptote in this case. So we aren't going to come there either. So how do we graph this? Well, of course, we can always graph it on the calculator. But you need to know how to deal with these. So let's just think about plotting points. For example, if we put in x equals 0, so we can find the y-intercept, we see that we have to be at 1/2. And then if you look at this, you'll notice that over the line y equals 2, it's symmetrical because of this absolute value. So you get mirror images across this line x equals 2. Now the biggest thing I want you to know about graphing these is being able to look at a graph your calculator gives you and know whether it's right or not. And sometimes when your calculator gives you a graph, if there's an asymptote, the graph will just suddenly stop, and you need to know that, oh, there's an asymptote there, so really it skims along the edge there. All right, let's try another one. Let's say we have a function g of x equals 1 over 2x squared plus 7x minus 15. So again, it's a reciprocal of a polynomial. So if we want to know where our vertical asymptotes are, we have to find the zeros of the bottom. So this factors to 2x minus 3 times x plus 5, which means that if x is equal to 3/2 or -5, the bottom is equal to 0. So that tells us our domain is x such that x is not equal to 3/2 or -5. So that means in our graph, at these places, we've got these vertical asymptotes. Where the graph the function's not defined. Now, the other thing we can look at is the range. Well, can this be 0? No, again, we've got 1 in the top, so it can't be 0. But could it be positive or negative? Yes, we could end up with negative numbers. So the only thing, the range we have to deal with is it can't be 0. So you can graph this on your calculator, and because you know that you have these intercepts here, or these vertical asymptotes here, you can find the picture and see what it looks like. Now you should be able to tell what the y-intercept is because that's fairly simple. That's plug in x equals 0. So this right here should be the point 0, -1 over 15. So the biggest thing with these reciprocals is that bottom function, making sure it's not equal to 0. So we use our techniques mostly from the polynomials right now to find the zeros of the bottom, figure out where our asymptotes are going to be. Once we've figured out our asymptotes, you can graph it on the calculator and draw a sketch. But you need to make sure you label your intercepts and draw in those asymptotes because your calculator may not let it look quite right with that. So let's look at the calculator here. See if we can get it to pull up. So if we want to put this equation in, we've got 1 divided by, now when you are pulling in these reciprocal equations, you have to make sure you put everything in parentheses on the bottom so that you've got the whole thing on the bottom of the fraction there. Now, you can see here, if this is a standard window, it doesn't really show you a whole lot. That's because these are where these asymptotes are. So let's adjust our window. Let's just go out to -8, and then our x max, since our asymptote's at 1.5, let's just go out to 5 on that one. And then our y minimum, let's just go -5 to 5 and see what happens. And it's going to freak out again. So here's our graph. All right, Now if you look at this, the calculator does not draw in the asymptotes, and you see it's close enough up here on y equals 0, it looks like it is actually touching it. But we know, because we looked at the algebra of the graph, that we have these asymptotes here, and we know that it's not going to be equal to y equals 0 because it's a reciprocal function. So I just wanted to show you that on your calculator it'll give you a good idea of what it looks like, but you have to realize where the asymptotes are and what it can and can't be, just so that you can figure out the what the calculator is trying to tell you. So make sure you have some good notes and that you've read this section 3.6 so that you can ask whatever questions you have in class the next time we meet. And hopefully we will answer all those things and take care of that.